the combination of thin lenses in contact. Thin lens antandre, what is thin lens? Thin lens is nothing but the lens whose refracting angle is less than 10 degree. ಆ ಲೆನ್ಸ್ನ ನಾವು ಥಿನ್ ಲೆನ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಅಂಥ ಎರಡು ಲೆನ್ಸ್ನ ನಾವು ಕಂಬೈನ್ ಮಾಡಿದಾಗ ಒಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರುತ್ತೆ ಫೋಕಲ್ ಲೆಂತ್ಗೆ. ಆ ಎಕ್ಸ್ಪ್ರೆಷನ್ನ ನಾವು ಇಲ್ಲಿ ಡಿರೈವ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಓಕೆ, ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಟೂ ಥಿನ್ ಲೆನ್ಸಸ್ ಹಿಯರ್. ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಫೋಕಲ್ ಲೆಂತ್ f1 and focal length f2. These are placed in contact with each other. Let us consider O is the object placed here. O is the object placed here. U is the object distance. V is the image distance for the image I. V1 will be the image distance for the image formed at I1. Okay, since I1 is the real image, it serves as the virtual object. This I1 is a real image. It serves as a virtual object for the second lens here, producing the final image at I. And since these lenses are thin lenses, we assume that their optic centers are coincident, that is at point P. Okay, optic center antandre eno? Optic center is nothing but the center of the lens, the central point of the lens. ಈಗ ಸ್ಪೆರಿಕಲ್ ಮಿರರಿಗೆ ಬಂದ್ವಿ the central point of that spherical mirror we call it as the pole. In case of the lens we call it as the optic center. It is denoted here by the letter P. Okay, then for the image formed by the first lens, that is image is formed at the point I1, we can write the thin lens formula is 1 by V minus 1 by U is equal to 1 divided by F, where V is nothing but the image distance, U will be the object distance, and F will be the focal length. For your syllabus you are having just to mention this expression. Okay, here the image distance is nothing but V1. We can write this one as 1 by V1 minus object distance is 1 by U is equal to 1 divided by F1, that is the focal length of the first lens. Take this as equation number 1. Okay, similarly the image formed for the second lens, image is formed at I1 will be the object here. Then according to this formula, the image formed for the first lens, it becomes 1 by V. Becomes the object distance, then minus the image distance means it is taken as V. Object distance is V1. 1 divided by V1 is equal to 1 divided by F2. Take this as equation number 2. Now add equations 1 and 2. On adding equations 1 and 2, you will get 1 divided by V1 minus 1 by U plus 1 by V minus 1 by V1 is equal to 1 divided by F1 plus 1 divided by F2. Okay, 1 by V1 and 1 by V1 it gets cancelled. Remaining is minus 1 by U plus 1 by V. We can write this one as 1 by V minus 1 by U is equal to 1 divided by F1 plus 1 divided by F2. Okay, suppose we replace this in the two lenses. We are going to consider here the two lenses, two thin lenses. If the two lens system is regarded as the combination, then it becomes 1 by V minus 1 by U is equal to 1 by F1 plus 1 by F2. This will be equal to 1 by F for the combination of two thin lenses. Then this will be the expression for combination of two thin lenses in contact having the focal length F1 and F2. 1 by F is equal to 1 by V minus 1 by U. Okay, this derivation it carries 5 marks in the final examination. Along with the diagram you have to derive this expression. Okay, linear magnification, this is for the lens. Linear magnification is M is equal to H dash divided by H, which is equal to V by U, where this H dash is nothing but the size of the image and H will be the size of the object. So The ratio of size of image to the size of the object, it is nothing but the linear magnification of a lens. Next term we are going to study is the power of the lens. It is represented by the capital letter. Power of lens is defined as the ability of the lens either to converge or diverge a ray of light, or we can also simply define it as, in a simple form we can define it as the reciprocal of the focal length is taken as the power of the lens. Okay, in the problems you will be asked to calculate the focal length when you are given the power of the lens. In that case we are going to use this expression which will be asked for 2 marks. ಒಂದು ನಿಮ್ಗೆ ಪವರ್ ಆಫ್ ಲೆನ್ಸ್ ಕೊಡ್ತಾರಾ, ಫೋಕಲ್ ಲೆಂತ್ ಕೇಳ್ತಾರಾ, ಅಥವಾ ಫೋಕಲ್ ಲೆಂತ್ ಕೊಟ್ಟು ಪವರ್ ಆಫ್ ಲೆನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಕೇಳ್ತಾರೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಪವರ್ ಆಫ್ ಲೆನ್ಸ್ ಈಸ್ ಆಲ್ವೇಸ್ ಪಾಸಿಟಿವ್ ಫಾರ್ ದ ಕಾನ್ವರ್ಜಿಂಗ್ ಲೆನ್ಸ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಆಲ್ವೇಸ್ ನೆಗೆಟಿವ್ ಫಾರ್ ಅ ಡೈವರ್ಜಿಂಗ್ ಲೆನ್ಸ್. And the SI unit of this power of lens is dioptry. Okay, this dioptry, it is represented by the capital letter D. It is represented by capital letter D. SI unit of this power of lens is taken as dioptry. It is always positive for converging lens and negative for the diverging lens. We are going to just mention the terms here. So these will be asked for 1 marks or 2 marks in your annual examination.